This is a question from operating system. Given as 4 GB is equal to 4.3 into 10 to the power of 9 bytes of virtual space, and a typical page size is of 4 KB, and each page table entry is of 5 bytes. How many virtual pages would this imply, and what is the size of the whole page table? This is the question that we are asked. So, to find out the answer, let's try to calculate the number of virtual pages first. So basically, virtual address space can be calculated as number of pages into the size of each page. Size of each page. This is the basic formula for virtual address space. Typically, this would represent, we can represent it like this. Assume this is the total virtual address space, and the total virtual address space is divided into pages like this. This represent one page. So the total virtual address page will be number of pages, like we'll count how many pages are there, and size of each page size. Based on these two, we are calculating the total virtual address space. So it is mentioned that virtual address space is 4.3 into 10 to the power of 9 bytes. This is equal to number of pages, that is, let's assume it as n, into size of each page is 4 kilobytes. So let's take it as 4 into 10 to the power of 3 bytes. So n, number of pages, is equal to 4.3 into 10 to the power of 9 divided by 4 into 10 to the power of 3. This would imply 1.075 into 10 to the power of 6 pages. 10 to the power of 6 pages. This will be the total number of pages that are involved. So this will be the first answer. Total number of pages. 1.075 into 10 to the power of 6 pages. So let's see if any option is matching. None of the options seems to be matching with the answer that we are currently having. Now let's try to calculate the size of the whole page table. So size of the whole page table. So basically, the page table will be consisting of what? There will be different pages here, and one entry will be having a page table entry size. Page table entry. This will be the basic formula. So size of whole page table is equal to number of pages into page table entry. Page table entry size. So it is given that number of pages is equal to 1.075 into 10 to the power of 6 pages, that is multiplied by 5 bytes. So we'll get an answer of 5.375 into 10 to the power of 6 bytes. We can assume it to be almost approximately equal to 5.375 MB. So both the options are not present in the 4 options given below. So this is one answer. This is also not present, and the previous answer 1.075 into 10 to the power of 6 bytes, that is also not present in the options given. So ideally, none of the options match. None of the options match. Options match. This is the point to be focused.